Hello, so in this video I'm going to be going over the programming on the previous video, and pretty much what I'm going to do is code it in Python and then plot it out. So I went ahead and imported all the things we will need. This numpy as np will just import Python programming. The make subplots from Plotly will allow us to use this make subplots command, and same for the solve banded from SciPy Lineage. It will let us use this solve banded. And I also went ahead and typed out some of the givens that we would have. We have alpha equal to 1, the in increment, which is number of increments, equal to 100, and the t increments equal to 2000, which is number of time increments. So if we hit Shift Enter, it all works. So now what we are going to need is a dx, which is kind of like the change in x, and we will have this equal 0.5. We want a dt, which is equal to change in time, which we will also have equal to 0.5. And we are going to define a variable x that we will use when making the graphs. So we will do np.arrange in inc and times by dx. So now if we look at our x array, you can see that it's just increasing by 0.5. So we can go ahead and get rid of that. And now what we are going to do is, in our equation from previous video, we set a variable r equal to alpha times dt over dx over 2. So we are going to do that, and it is dx squared, actually. So we hit Shift Enter. All right, it looks good. And now we are going to make an array called t. And we want this array to be the size of the in increments, and we want to fill with values of 20. And we are also going to define the initial starting value and the final value. So to do that, we are going to do t bracket 0, which will give us the first value since Python indexing starts at 0. We are going to set that equal to 50. And we are going to set the last value equal to 80. So now if we hit Shift Enter, all right, so far so good. So now if we want to see what t is, you can see our initial value is 50. It's all 20s, and our last value is 80. So that's all good. So now what we want to do is we are going to make two matrices. One of these we are just going to simply call A, and this will be a multi-layered matrix rather than just a straight-on array. So what we are going to do is use np.zeros, and the shape will have two dimensions, which will be 3 and the number of increments minus 2. And we are going to also have some of the values. This should be a comma. So what a bracket 0 to 1 on pretty much means is it's that length of code, and we are going to have that equal to negative r. We are now going, that's annoying. Okay. Now we are going to have 1 on, and this will be equal to 1 plus 2 times r. And I didn't mean that bracket. And we are also going to have from a of 2 and then negative 1. And this will be equal to negative r as well. So pretty much what these indexings mean is here we have 3 rows. We have 3 rows from 0 to 2. And this just means like from 1 on, which this would be 1 for the first row, for the first section. This is second section, third section. This is all values. This is values up to the last one. So now if we hit Shift Enter and we want to see A, that's about what we'd expect. So now our second matrix is much easier because we aren't doing a multi-layered one for our second matrix, and we will just call that B. We will have np.zeros of inc minus 2. And we will have B equal to R times T 2 on, then plus 1 minus 2 times R, and times T 1 negative 1, and we will have plus R times T to the negative second. So next we are also going to have the initial values. For B, we're going to set them equal to B0 plus R times T0. And we are also going to have the last value of B, similarly as above, equal to B negative 1 plus R times T negative 1. All right, so far so good. So if we hit Shift Enter, that all looks pretty good. So now what we are going to do, since we have our 2 arrays, is we are going to actually start to make the subplots for them. So what we are going to do is use the make subplots command. Have the rows equal to 1 and the columns equal to 1. And we are going to do fig.add scatter, in which x will be equal to x, y will be equal to t, and name of this we will call crank. And we are also going to add a for loop for I in range t increments plus 1. And we are going to do some stuff with the solve banded function. So we will have the solve banded, in which this is 1, 1, and we will have A and B. So now we are going to also have more stuff on inside similar to above. So we will have B equal to R times T to 2 on, and plus 1 minus 2 times R. Actually, above, I just realized I didn't space out that R. That's annoying me. So if you notice, it's pretty much the exact same as up here. Actually, it may just be better copy and paste, because I'd just be rewriting everything up here. That would have been much faster. But you have to make sure this indents. And we are also going to have an if condition for it will be, if it's easier to type it out and me say what it is. So what this is pretty much saying is, if I divided by 100 has a remainder of 0, so all increments of 100, then it will do our next command, which we will have big add scatter, in which x equals x, y equals t, and we will have the name equal to f times dt. All right, so we hit Shift Enter. All right, good. So this is the graph that we wanted. As you can see, they're all kind of like converging to the same line. They all start at 50. They all end at 80. And it's about the graph we would estimate for this. So that is how you program out the previous part into Python and make a graph for it.